right, here's section 4.5 and 4.6. These are two very similar sections. I combined them together. We're going to multiply polynomials. So starting out with our special named polynomials, we have a monomial times a monomial, one term times one term. All we're going to do is use your commutative property of multiplication to regroup the things being multiplied together. So I'm going to take the coefficient 5 and the 4, bring them together. X squared and x to the 5th, bring them together. So you want to visually see this happening and say, okay, if I bring the 5 and the 4 together, that's 5 times 4, that's 20. X squared times x to the 5th, add my powers because I'm multiplying like bases. We're going to get 20x to the 7th. So next we have 3x to the 4th y squared times 7x to the 6th y to the 3rd. So if we try this between our ears, we're going to go 3 times 7 is 21. X to the 4th, x to the 6th, that's x to the 10th. Y squared times y cubed, that's y to the 5th. So again, here it is written out, but this is what you should be picturing and going through this multiplication between your ears, writing out your answer as you go. Now we have a monomial times polynomial. So we're going to see binomials, trinomials, maybe even a 4-term polynomial. This is nothing more than the distributive property. We're going to take your monomial and distribute it and multiply to each term in the second set of parentheses. So 3x gets multiplied to 5x. 3x gets multiplied to the minus 7. So again, we're looking at 3x times 5x. Okay, think of that as 15x squared. 3x times the 7. The minus stays with the 7, becomes a minus 21x. If there's 3 terms, then we're going to draw 3 arrows to each term. 4x squared times x squared. 4x squared times the 3x, keep the minus sign. 4x squared times the minus 2, keep the minus sign. So we'll have 4x to the 4th minus 4 times 3, 12x to the 3rd. If you need to put a 1 here, you're more than welcome to. Minus 8x squared. So 4.5 is the multiplying by the monomial. 4.6, now we're going to introduce the binomials times binomials or trinomials. So here, this is sometimes referred to as the double distributive property or the FOIL technique, where FOIL stands for the first terms being multiplied in the binomials, the outer terms, the inner terms, and the last terms, which is the same thing as if you will say we're doing a double distributive property. So first terms in my parentheses, x times x, x squared. Outer terms, x times the minus 3, minus 3x. So that's the distributive property of the first term. Then we're going to take this plus 6 and we're going to distribute that as well. 6 times x gives me plus 6x. That's the 2 inner terms of my binomials. 6 times a minus 3 is a minus 18. Those are the last terms in my parentheses. Combine the 2 middle terms, we get x squared plus 3x minus 18. And that is in descending order and simplified. Now, one thing that I want to point out is that if your terms are the same in the parentheses, that means first term and first term are like terms. Second term, like terms. You will combine the 2 middle terms every time. Notice in these two binomials, 3x squared is not the same as x. So here, the middle terms will not combine together. So if we multiply this out, 3x squared times x is 3x cubed. 3x squared times a minus 4 is a minus 12x squared. 5 times the x, that's a plus 5x, and 5 times the minus 4 is minus 20. You'll notice the 2 middle terms are not alike, therefore there's no combining of like terms, and this is our answer. The next 2 set of binomials, you'll notice something here, and you're going to come up with a shortcut. If I were to FOIL this, x times x is x squared, x times minus 6 minus 6x, 6 times x is plus 6x, and 6 times minus 6 is minus 36. X terms to the first power, constants of 6, they're like terms. Middle terms combine, and you're going to notice that they are opposite signs because one was a plus binomial, one's a minus, and the first and last terms were the same. Doesn't matter if it's plus minus or minus plus. The middle terms will cancel. So a shortcut to this is if you see that you have what we would call conjugate pairs. Two binomials that look the same except one's a plus, one's a minus, or again it can go minus plus. The two middle terms will always cancel. So a shortcut is just to take the first term times the first term, last term times the last term, gives you a squared minus b squared. So if we try that out here, 2x times 2x is 4x squared, plus 3 times minus 3 is minus 9. You are done. But again, you have to recognize these conjugate pairs. First term the same, second term the same. The difference between one's a plus, one's a minus, or minus plus. My next example is now we have binomial squared, where again, raised to a power means you have to write out this binomial twice and FOIL it. Do not go x squared and then minus 3 squared to get a plus 9 or minus 9. No. You FOIL this out. There's going to be a middle term. You're going to get x times x is x squared. X times the minus 3 is minus 3x. Another minus 3x. And negative 3 times negative 3 is a positive 9. So what you should be noticing here is that the two middle terms are now going to be exactly the same, whereas up here they were opposites. So there will always be a middle term in a binomial squared. If we try that again, we have x plus 5 squared. We write it out twice. X times x is x squared. You're going to get 1 plus 5x, another plus 5x, and 5 times 5 is 25. Middle terms are the same. Combine those together to get 10x in the middle. Now, you should recognize a pattern here. X squared, 3 squared, positive 9. X times a minus 3 is a minus 3x, but you always have two of them, so we double that. All right, so there is a pattern written out, if you like formulas, if it's an a plus b squared like this one was, where everybody comes out squared. Your 2ab is your 2 times x times the 5. So 2 times x is 2x times 5 is 10x. All right, I'm not big on memorizing formulas. I like to memorize techniques. I call this the smile technique because it's technically using your arrows up above here for foiling without writing it out twice. So 2x times 2x is 4x squared. Then 2x times 5 is going to be 10x, but then you double it to 20x. And then positive 5 times positive 5 is 25. So here's my F arrow, my O arrow, my I arrow, then my L arrow, and by combining it like this, you can see my smiley face. Okay, now we have a binomial times a trinomial and a trinomial times a trinomial. So there's a lot of multiplication going on here. You need to keep track of your information. So one technique to do this is to always make sure your binomials out front. If they put the trinomial first, switch them around. So when we draw our arrows, x times 4x squared, 4x cubed. X times minus 5x, minus 5x squared. X times minus 3 is minus 3x. Now here's where you want to organize. Once you start this 2 being multiplied to these terms, start to line up your like terms. So 2 times 4x squared is a positive 8x squared. Write it underneath the minus 5x squared. Don't put it off to the side here because now you got to go back and forth. Everything's lined up vertically. 2 times the minus 5x will be a minus 10x. We'll put that underneath our minus 3x. 2 times the minus 3 is a constant, minus 6. It's out here by itself. And now we just add things together vertically. 4x cubed, negative 5 plus 8, positive 3, keep the x squared. Minus 3 minus 10 minus 13, keep the x, minus 6. When we get to a trinomial times a trinomial, now we're going to have more arrows, but we don't have enough room. X squared could go over the top, minus x goes on the bottom, and then plus 2 is going to get crisscrossed in here. So here is another technique that you want to think about doing. Look to see who has the easiest coefficients to multiply by. 1, negative 1, and 2 are easier to multiply than 4, negative 5, and 3. So I'm going to line up the easiest coefficients underneath the other trinomial. Now, parentheses are optional here, and I'm going to treat this like a 3-digit number times another 3-digit number. So when I multiply this number here, this ones place digit, you got to multiply it to this ones place, this tens place, this hundreds place. So it's going to be like doing a distributive property, but you're going to use the same techniques when you did your old multiplication of 3-digit numbers. So 2 times negative 3 is negative 6. 2 times negative 5x, negative 10x. 2 times 4x squared, positive 8x squared. Now we're done. We're going to go to our next digit, the minus x. All right, now if you remember back in the good old days, you used to put a 0 here. If you want to put it there to hold that place value or that like term, it's optional, but you don't have to do it. Minus x times minus 3, that's a plus 3x. Remember to take the minus sign with it. Line it up underneath the minus 10x. Negative x times negative 5x, that's going to be a positive 5x squared. Negative x times a positive 4x squared, that's going to be a negative 4x cubed. We just keep building out. All right, now we're going to go to the third digit, which means, remember, you used to put in 2 zeros here. Again, it's optional. You don't have to do this, but it kind of reminds you of the good old days when math was fun. X squared times a minus 3, minus 3x squared. Keep lining them up so it's going to be easier to combine these together. X squared times minus 5x, minus 5x cubed. X squared times 4x squared, 4x to the fourth. And now we add vertically. No carryovers. All right? Nothing to combine to 4x squared. Minus 4 minus 5 minus 9, x cubed. 8 plus 5 is 13, minus 3 is a positive 10. Keep the x cubed. Minus 10 plus 3 is minus 7x. Bring down the minus 6. And there they are, all multiplied out. All right, to 4.7, polynomials in multiple variables. We can still evaluate this, but the biggest thing here that you're going to remember is there's not going to be descending order, and there's not going to be a leading term or leading coefficient. So one thing that I would encourage you to do, if you have to evaluate a polynomial with multiple variables, we're going to want to use parentheses and or brackets. So I'm going to use blue parentheses because I have the ability to use color. So if you got a blue pen, we're going to put parentheses around every x, and we're going to put a negative 2 in. And then I'm going to use red parentheses for my y and put red parentheses around every y. Now, if you don't have color, we'll go parentheses and a bracket. We'll put a negative 2 in for every x, and we'll put the 5 in for every y. Now, again, we're going to go through individually here to evaluate them. So the 4, done. 3 times negative 2, minus 6. Negative 2 times 5 squared. It's not negative 10 squared. You got to do the 5 squared, which is 25, times negative 2 is negative 50. All right, now this next one, this is going to be a shortcut technique. It only works because notice that both powers on the x and the y are exactly the same. This is the only reason why it works. So I have negative 2 to the third, 5 to the third. Because these two powers are the same, I can multiply the negative 2 and the 5 together and make that a 3. Now, why do I want to do that? Is because I know that 2 times 5 is a 10. And multiplying by 10s means you just add zeros to the end. So negative, I have 3 negatives, which keeps us negative. 10 to the third is a 1 with 3 zeros. Multiplied to an 8 is a negative 8,000. All right, and we'll just add these all together, or in this case, do a lot of subtracting here. 4 minus 6 is negative 2, minus 50 is negative 52, minus 8,000 is a negative 8,052. So a little sneaky trick there to help your calculations go by quicker. All right, next we have the surface area of a circular cylinder is given by the formula 2 pi rh plus 2 pi r squared, where h is the height and r is the radius. So we have multiple variables, r and h and r squared. Pi symbol is a value. Approximate the surface area for a can with a height of 4.7 inches, that's my h, and a radius of 1.2, that's my r. So again, go with parentheses, different colors, or parentheses and brackets. If you can do just straight parentheses, that's fine. So my surface area is 2 pi times the r, 1.2, times the h, 4.7, plus 2 pi times, in parentheses for my r squared, 1.2 squared. So here you got to be careful and read the directions very carefully. If the directions want the answer in terms of pi, you treat pi like a variable and leave it in your answer. So we would probably go to a calculator and go 2 times 1.2 times 4.7 is 11.28, include the pi symbol. We'll go 1.2 times 1.2 times the 2 is 2.88. Keep the pi symbol, combine them together because they're like terms to come up with 14.16 pi, and because it's area, it's square inches. Now, if the directions tell you to use 3.14 for pi and not the pi symbol on your calculator, make sure you use 3.14. So 14.16 times by 3.14 now gives me this big decimal, 44.4624 square inches. Now, we all know that pi goes without end. It lasts forever. So if you did use the pi symbol in your calculator, this answer is going to be bigger, and it's going to be wrong because you didn't follow the directions of using 3.14. I know it's ticky-tacky, but you have to read the directions, okay? All right, combining like terms when you have multiple variables. What I would do here is keep your variables in alphabetical order. So as you read through it for the very first time, look at your letters. X, Y, X, Y, X, Y, X, Y. If somebody has got a YX, switch them. So let's say this was YX squared, switch it around so it's X squared Y. You'll see a lot of ABs and Cs, BACs, CABs. Put them in alphabetical order, and just remember that the exponent, the powers, have to stay with those variables. Next, we're going to go out and try to identify like terms. All right, so the only like terms I see is an x to the first y squared, x to the first y squared. So I'll combine those together to get a 2xy squared, the 9x squared y cubed, no match, the minus 5x squared y, no match. These are the only two you can combine, and that's my final answer. All right, find the degree of the terms and the polynomial. All right, so in this example, we have 9x squared y cubed minus 14x, whoops. We might want to put a 1 here, x to the first, y squared z cubed, xy, 1 and a 1, 4y, put a 1 up there, 5x squared, and y to the 7th. So now that you put your 1s, we'll go to each term. I see a 2 plus 3. That's a 5th degree for that term. 1 plus 2 plus 3, that's a 6th degree. 1 plus 1, that's a 2nd degree. Here's a 1st degree, 2nd degree, and remember constants are always a 0 degree. What's the degree of my polynomial? Who's the biggest degree? That's the 6th degree. That's the degree of my polynomial. Performing the indicated operations, notice again we have a mixture of variables, x's and y's. So when I see this here, I do nothing more, because I'm adding, is I'll just start with my very first term. Negative 5x cubed. Look for another x cubed. Here it is. Combine them together, 3x cubed. Cross them off. Now take your y term. Look, no other y, put it in your answer. Cross it off. Next, we have a minus 5y squared. I'm looking for a y squared. It's right here. Okay, negative 5 plus 7, 2y squared. Cross them off. Then plus 4x squared, put it at the end. There is no proper order to put these in. So I suggest you just work from left to right till all the terms have been exhausted. Quickest and easiest way that I know to do this problem. Here we have this mixture of terms here with x's and y's with a minus sign. Whoops, timeout. What do we got to do with this minus sign? We have to distribute the minus sign. So again, change all the signs. Minus 4x squared y. Just write it right down below here as we go. Plus 6x cubed y squared minus x squared y squared plus 5y. Again, optional to copy this down, or you can just leave it kind of at an angle here. Well, again, like I said, start with the far left. I have a 4x squared y, looking for another one here. Oops, wait a minute, it's a minus 4x squared y. They cancel out, they're opposites. Now I'm looking for an x cubed y squared. Here's an x cubed y squared. Add those together to get 7x cubed y squared. 1 plus 6 is 7. Cross them out. Next, we're looking for an x squared y cubed. I don't see an x squared y cubed. Put that in your answer. Cross it off. I have a 6y, looking for a y term. Here's another one, 5y. Add those together. We get a plus 11y. Cross them off. We're left with a minus x squared y squared as my last and only term. Put that in there, and we are done. Multiplying doesn't change. It's just that you're going to have different terms here. So you have an x term, y term, y term. So the middle terms should cancel. So as you FOIL this, x times 2x is 2x squared. X times a minus 3y is a minus 3xy. Plus 5y times plus 2x is a plus 10xy. Notice my variables are in alphabetical order. See, these are like terms. I'll be able to combine that in a second. 5y times negative 3y minus 15y squared. We'll combine that in the middle to get 7xy, and there's my final answer. All right, to the right here, looks like we have a trinomial times a trinomial. And this is going to happen to you, okay, where you might want to just maybe not write anything down right now. Just watch. So you line up the second one under the first, or the first under the second, it doesn't matter. And you start to multiply these out. We'll get a minus 4y squared, a plus 6y, a plus 4xy. Then multiply the 3, 2, we get a minus 6y, so I line it up, a plus 9, no match, make a column for it. 3 times 2x, 6x, no column, make a new one. 2x times minus 4y, we have a 4xy, line it up underneath there. 2x times 3, that's going to be a plus 6x, put it there. 2x times 2x is 4x squared. line them all up, start adding them. 4x squared, we got plus 12x plus 9. Opposites cancel, minus 4y squared. That's my final answer. Okay, now, however, there's a lot of canceling going on, and there's a reason for that. Notice it was 2x, 2x, plus 3, and then a minus 2y and a plus 2y. Folks, we can do a little manipulation to save on all of this work. These two trinomials can be rewritten as a conjugate pair of binomials. What do you mean? There's three terms. How do you get two terms? You put a grouping symbol around the 2x plus 3. They're exactly the same. We're going to treat this like one term. Remember, the definition of a term is any number, variable, or quantity being multiplied together. All right, my 2x plus 3 is being multiplied by 1. Notice the minus 2y plus 2y. So now, remember when you multiply a conjugate pair, you take the 2x plus 3, first term, multiply to this first term. That's 2x plus 3 squared. Negative 2y times a positive 2y is a minus 2y squared. Okay, now stop and think. A binomial squared, Mr. Fitz-a-Smile technique, 2x times 2x, 4x squared. 2x times 3 is 6x. Double it, 12x. 3 times 3 is 9. Minus 2y squared minus 4y squared. Holy cow, there it is. Look at the amount of work you just saved. 1, 2, 3, 4, 5, 6, 7, 8, 9 steps for multiplying. 10. If you want to call it those as steps, 11 and 12. 12 steps here. Okay, how many here? Just to rewrite. 1, 2, 3. Double it. 4, 5. Half the steps to get to that work. So look at those trinomials. You might get a 2x minus 2y plus 3. 2x plus 3 plus 2y. If you see that there's a difference of 1 plus 1 minus, you can always rearrange, find the things that are exactly the same and putting them front. Put the opposite signs at the end. Create your brackets around here. Boom, boom. I just put them in, and now it becomes this right here, and you multiply a conjugate pair together. All right, a cubed minus 7a squared b, all this to the power of 2. Okay, that's a binomial. Let's do our smiley technique. Here we go. A to the third times a to the third, a to the sixth. A to the third times 7a squared. That'll make it a to the fifth times b. So minus 7, a to the fifth b, double it, minus 14, a to the fifth b. All right, here we go. Negative 7 times negative 7. We're going to get a positive 49, a squared squared, a to the fourth, b squared, and you're done. There's my answer. I hope you enjoyed some of these shortcuts that you might encounter in the homework.